Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us first understand the key concept here. The starting material is cyclohexyl methyl ketone, a ketone with a methyl group. The product is cyclohexane bearing a CH, CH3, CH to CH to CH3 group, meaning the carbonyl oxygen has been completely removed and replaced by two carbons, one CH3 already present, one new CH to CH3 chain added, with a CH bond at the former carbonyl carbon. This is a net replacement of C is equal to O with CH plus extension of the carbon chain, which is characteristic of a Wittig reaction followed by reduction. Moving on to the next step. Using the ylide C6H5, 3P is equal to CH to CH3, a stabilized or semi-stabilized ylide with a propyl chain, the Wittig reaction with cyclohexyl methyl ketone converts the C is equal to O into C is equal to C, giving the alkene, cyclohexyl C, CH3, is equal to CH to CH3. This installs the new carbon chain and eliminates oxygen. And for the final step, B2H6 diborane, followed by CH3CO2H, acetic acid as a proton source for workup, reduces the resulting alkene via hydroboration. Hydroboration of the trisubstituted alkene cyclohexyl C, CH3, is equal to CH to CH3 with B2H6 gives an organoborane, and protonolysis with CH3CO2H, a proton source that cleaves the C to B bond, gives the reduced alkane, cyclohexyl CH, CH3, CH to CH3. This matches the product exactly. Why other options fail? A. Grignard addition of CH3CH to CH to NGBr to the ketone gives a tertiary alcohol after H3O plus workup. PCC oxidize secondary primary alcohols, but cannot oxidize a tertiary alcohol, so no further conversion occurs. Product would be a tertiary alcohol, not the desired alkane. B. Same Grignard gives tertiary alcohol, H2SO4 heat causes dehydration to an alkene, then PCC cannot oxidize a simple alkene to the desired product. This does not give the target molecule. D. Wittig with C6H5, 3P is equal to CH to CH3 alone gives the alkene, but H2O alone cannot reduce the double bond. The alkene would not be converted to the saturated product without a reducing agent. Option C uses the Wittig reagent to form the alkene intermediate and then uses B2H6CH3CO2H to effect hydroboration followed by protonolysis, delivering the correct saturated product cyclohexyl CH, CH3, CH to CH3. Therefore, the correct answer is C. Therefore, the correct answer is option C.